Hello, everyone. Welcome to this session titled Cloudstate Towards Stateful Serverless. I'm Jonas Bonér. I'm the CTO and at Lightbend, and I'm joined by James Roper, Senior Architect at Lightbend. And we will try to give you a little glimpse into what we believe will be the future of the cloud, at least part of the future of the cloud, through the serverless experience. See. So I just want to start by saying that a lot of people talk about serverless and as the same thing as function as a service, but for me that's not really true. I think function as a service, FaaS in short, is a really good first step. It was really groundbreaking when it came about, and it's really been sort of showing the way, showing what's possible. But it's only the first step on a long journey towards this, nirvana, this amazing cloud experience that we all hope to get to one day. So for me, so serverless is really all about an experience for developer, for operations, for deployment that is completely new. In order that one that sort of removes as much as possible from the essence, and moving it away to the runtime, to the back end. So you as a developer, or we as developers, can focus on only the essence. And what I would like in my sort of grand vision for the future of the cloud, I would like to build this build any type of application, build sort of general purpose application, full applications in this new experience. Function as a service is currently sort of tackling one subset of the use cases in a non-trivial application. Sometimes a large portion, sometimes a small portion, but it's just really hard to tackle everything that we need in a non-trivial real world application in just function as a service. So we need something more. So the question is then, what is the missing piece? What is missing here? And I believe that it's state. It's good ways of working with state, solid models for abstracting over state, to essentially having good ways of abstracting over state so the runtime can manage it for us effectively. And so some of the technical requirements that I see that we need in such sort of new way of writing any type of application in this new experience is first support for stateful, long-lived, addressable components that can be virtual as well. It means that you have stable references, stable addresses, but they can still move around, maintaining their data integrity and their state, while the address remains stable. So even if they're relocated, passivated, activated, you can still trust the reference talking to it, and don't need to worry if it fails and it's respawned, etc. We need a wider range of options of tools in the toolbox, so essentially, for distributed coordination and communication. PubSub, like we have in functions as a service, is great, but it's only one way of communicating. I believe we also need support for point-to-point, for broadcast, and for things like modeling orchestration of workflows, using things like sagas, process managers, etc. We also need options for managing distributed state reliably at scale, and not just having one size fits all. Not saying that everything needs to be strongly consistent or everything is eventually consistent, but having options ranging from strong to eventual through causal consistency. So you can fit serve the weakest model that gets the job done. Because if you add layers of safety, of guarantees on top that you actually don't need, that's wasteful. So you actually want the minimum guarantees that gets the job done, that liberates the runtime to do even more things in terms of scale and availability. Okay. We also want intelligent, adaptive placement of stateful functions. Things like sharding, having a physical co-location of state and processing, as well as sticky routing. These are very important things in order to manage data at scale, performantly at scale. Function as a service is really good at abstracting over communication. So you have your user function and you have your sort of message in. You don't need to worry how it ended up there. It just it sort of ends up on your mailbox or a queue to your function and passed into you for processing. And the same thing, message out. You only emit the event, and you don't need to worry about where it will end up, who's going to pick it up, etc., and the mechanics for doing so. You have well-defined interfaces for message in and message out, or event in and event out. And you just work towards those. But the problem is that sometimes you need to manage state. But if you talk to the database directly, you're sort of moving a lot of these operational concerns, the things that function as a service or serverless, rather I would say, is meant to manage for you. It's supposed to abstract away all these hard things, but by managing, so data access and usage from within your function yourself, you sort of eliminates that option from the table, essentially. And the problem is that now the function, is sort of a black box to the runtime. If the function manages state it's himself, the function can't sort of see in and understand what's really going on here. And it's a fact of sort of unconstrained database access, which sounds like a good thing. I mean, more power is good, right? But it's actually not always the case, because it makes it really hard for the runtime to automate operations on behalf of the function. So it's really hard to understand sort of the intention of each access. For example, is the operation a read or is it a write? Can it be cached? Can consistency be relaxed, or is strong consistency always needed? Can operations proceed during partitions and failures, etc. Right? If the runtime understands these things, it can make intelligent sort of decisions more effectively. And also, see broadly across all of your entities and making things, collectively optimized. And as Timothy Keller, once said, that freedom is not so much the absence of restrictions as finding the right restrictions, the liberating restrictions. So the question is then, what are those liberating restrictions? And as I said, the function service is really good at abstracting over communication. So you have message in and message out, as we just talked about. The question we asked ourselves at Lightbend was, is it possible to abstract over state in the same way that function as a service abstracts over communication? So instead of just message in and message out, you also have state in and state out. So it's sort of an inversion of control here. Instead of the function manages himself, the state gets passed to him, and he can just emit state. And all the sort of hard things around managing that, how the state is handled in the backend, is sort of delegated now to the runtime in a true serverless fashion. The problem is that CRUD doesn't always fit this model, but we need new models and new ways of thinking about the state. I'll get to that just in a second. So that was sort of the premise when we started Cloudstate, trying to answer the question: can we abstract over state in this way, and can we provide a stateful addition to function as a service that's great for stateless workloads? So the joint thing can give us the platform we need for general purpose applications. So what is Cloudstate? You can find out more after this talk if you go to cloudstate.io. But the overview is that first, it's open source, fully Apache 2. It's available on GitHub. You can just go and check it out and mess around with the code and contribute, ideally, if you like. The sort of short one sentence is really that it's distributed state management for the cloud in a serverless experience, as I talked about. And it's really two things. First, it's a reference implementation, but it's also standards or a protocol and a specification. So this is possible to create more than one implementation if people feel inclined. But the essence is that it lets you focus on your business logic, your data model, and your workflow. That's it, essentially, and how to configure declaratively these things. It's sort of leveraging Akka to do a lot of the heavy lifting, the cluster sharding and persistence and things like this across the nodes, the Kubernetes pods and things like that. All the hard things around state, both long-term durable state as well as like more short-term ephemeral state, coordination type of state, scratch data, and these things are managed by Akka. It leverages gRPC as a protocol, between the backend and the client. I'll get to that just in a second. It leverages Knative and Kubernetes, and also runs on GraalVM, which allows us to compile it down to native. Since Akka runs on the JVM, it's very important to minimize the memory overhead and the startup times. And GraalVM really helps us with that. So it's really polyglot, and here's where we sort of leverage gRPC. The gRPC sits right in between. It's a protocol how clients sort of make use of these sort of distributed state management, and essentially any language that has support for gRPC can be supported by Cloudstate, because essentially all these clients are gRPC clients, and we currently have support for JavaScript, TypeScript, Java, Go, Dart, Python, .NET, Rust, Swift, and Scala. Not all of them are complete, but a lot of them are being worked by the community as we speak. So it's really exciting to see the community pick these up and sort of cranking these client libraries out. It also supports like polystate. As I said, CRUD's not always the best answer to sort of the serverless state serverless story. But other models that I think fits better is that we support now in Cloudstate is event sourcing. I want the time to go through what that is really and how it works. But event sourcing is really, really cool. CRDTs, like, it's essentially conflict-free replicated data types. It allows you to share state freely in the cluster without worrying about race conditions and inconsistent data. It's eventually consistent, while event sourcing is strongly consistent. So it gives you two models for that. We also have key value storage. And it supports that across a wide range of databases, SQL, NoSQL, NewSQL, and also in-memory replication. So if we're just going to end by sort of zooming out a little bit, what it looks like, is that you can see on the right-hand side that that we can write functions or these entities or functions, stateful functions in any language. Like we can have, for example, a Python type of shopping cart. We can do Java implementation of an order, and we can have a JavaScript function implementing the inventory in this simple example. But the interesting thing is that for all the clients, web clients, IoT clients, they communicate over gRPC to these entities, but they do that through the Cloudstate proxy. And the Cloudstate proxy is sort of managing all the data on behalf of all these entities. It sort of populates them as needed, as they are requested, So all of these entities are always fully hot. They always have the latest data available. They're sort of truly, really endpoints, and the database sits in front of it. Again, having this inversion of control, where each entity is just, sort of sent the things he needs at each moment, so to speak. And the Cloudstate proxy looks across all of these entities and optimizes the data storage for all of these state models across all the entities you have. So that's all I had as an intro. So now James is going to give us a little demo here and go into more details about how things look and how you can get started with Cloudstate.
Thank you, Jonas. So I'm going to be giving a demo of Cloudstate in action. We're going to be building a conference app for asking questions and answers that allows participants to submit questions and then vote on those questions so that the presenter can then select them. I'm going to be demoing this. I've already written a UI for this, so you can see it here, and you can select a presentation. While this presentation is pre-recorded, I will ensure that when the presentation is actually given, that this will still be running. So if you want, you can go and play around with it now. Just be aware that this is not the official conference question and answer way to ask question and answers. So the UI is already written, and I've already set up some of the build files and things like that. So we're going to write this in JavaScript. Cloudstate supports a wide variety of languages, anything really that supports gRPC, but JavaScript is what we're going to use today. And so I've got a build file here with some things to help me get started there, a Docker file to help me build my Docker image, and the first thing that we'll look at is this Protobuf file. So every single Cloudstate service has to be defined as a Protobuf service. So you can see we have service Q&A here. We have two methods, ask. We've got some annotations here so that this can be consumed as a REST API from the browser. And then we've got this watch and some annotations here. So ask will be used both to ask a question as well as vote on a question, and watch will be used to get the current list of questions for a presentation and also to see them updated in real time. And that uses Cloudstate supports service and events when it's transcoding to HTTP. So something important to note about this ask request and watch request up here, they both on them define this presentation field, which is annotated with this annotation saying that the presentation is the entity key. This tells Cloudstate that the ID that's passed in this is the ID of the entity that we're going to be working with. So it allows Cloudstate to provide the user function with the state necessary to be able to perform the request for that for that request. So similarly, watch request has this presentation field with the entity key there. So let's dive into the code. So first thing that we're going to do is we're going to require the Cloudstate support library. So this provides an idiomatic JavaScript API to wrap the Cloudstate gRPC protocol. We're then going to create our entity, passing in that proto file, Q&A.proto, as well as the fully qualified name of that service that we've defined. So this is saying we're going to implement this entity, that service with this entity. And I'll set up a default value. So to implement this entity, we're using Cloudstate's CRDT support, or conflict-free replicated data types. The great thing about CRDTs is that they scale really well. You can update them from as many nodes as you want concurrently, and without any coordination, they will guarantee that all nodes will eventually reach a consensus as to what the correct state is. And so you can have a very high throughput of writes and as well reads. All the reads are local, all the writes are local, and then the synchronization of the state is done in the background. So it scales very well and can operate in the presence of partitions. So for each conference presentation entity, we're going to use something called an observed removed map. The keys of this map are going to be the questions themselves, and the values are going to be another CRDT called a counter, or a grow-only counter. So every time somebody votes, we'll increment that counter by 1. So we're going to implement our first service call here. It's the ask one. So when ask is invoked, we'll first check, do we already have that question? If not, we'll add that question with a new counter for it to our map of questions. And then we're going to increment the number of times that question was asked, so i.e. the number of votes for that question by 1, and we'll return empty because ask returns empty. And so that's the implementation of the ask service call. Next is a little bit more complex. We'll do the watch service call. So now, when something important to explain, so we have the request here, which is our gRPC request message, and the context here, which has the state and other things that we can interact with. So the first thing we're going to do when we watch, we'll create a helper function we want to convert this OR map CRDT to a map of the questions asked that we can send back as a Protobuf. So we will copy the map into an object of questions. So for each question and counter that we have in our map, we will set the question in the map we're copying to the current value, and then we can return the questions. And so now down here we can use that method to create the questions, and then we can return the questions. So that's going to return the questions initially when we do the watch request. But we also want to be able to send updates whenever a new question is asked or voted on. And so to do that, we're going to add an on-state change callback that will be able to send these updates. And I'm going to implement another helper function here. So given the existing questions that we've sent to the user and the current state of the map, we'll work out what are the updated questions. So iterating through the map, if the question either didn't exist before or if it's changed its value since last time, then we'll add that to our updated map, as well as updating the original questions map, and then we can return the updated. And so now we can use that to get our updated, and if there is anything in the updated map, we'll return it, which gets sent to the user. So now that we've implemented our watch call, we can register these as command handlers. So ask and watch, this maps back to these methods defined in here. And finally, we can start our server. And so that's everything that we need to do to actually do the implementation. You can see here, I've also got a descriptor. So while we're looking at that, I'm going to build use the npm to build that. We're just going to run some Docker commands. And once that's built, you can see here I've got this descriptor. So this is a Kubernetes descriptor for a stateful service. And all I need to do is say, here's the Docker image that is going to be run as part of the stateful service. And so now that my Docker image is built and pushed, I can apply that, which will create my service. Now if I do kube control get pods, you can see it here. Now it's not really that interesting to see these pods, to see it running in one node, because the point of Cloudstate is to be able to scale in a distributed system. So why don't we scale that up to 6 replicas? And so you can see that's coming up, and everything's should be running pretty soon. And these 6 replicas will form a cluster so that they can share and gossip that CRDT state. So now going back to our questions and answers, we can go to one of the presentations. We can say, does this work? Ask that question, and you can see it appears there. I can vote on it, and it should increase. Now, there's a little bit of a delay there, and the reason for that is that the node that the question asking the question is going to might be different to the node that is actually doing the watching, and so it takes a little bit of time for that state to be gossiped. If we have a look, we can see, if I go in another window, can I ask a question in a different window? We should see it appear in both windows. And so we can vote, and everything should update in both windows. And so now we've seen that Cloudstate can be used to implement using some distributed state patterns with not very much code in any language, a simple app like this. Thanks, Jonas.
Thanks a lot, James. That was a great demo. Now I think we have time for some questions. So if you have any, fire away.